Welcome back to Andersen Acres. We're here inside with Capricorn today because someone asked me to do something rather interesting. Someone asked me, a viewer, if I could kind of play color genetic detective with my rabbits. Explain what their genetics are, color-wise, so why he's not an agouti, and how I know what those genetics are. So that's a fun game, and we will start playing that game a little bit with some of our rabbits. So one of the rabbits that we want to start with here is Capricorn. He is my Holland Lop buck. So he is a big boy. He has fathered several litters with us, and he is absolutely gorgeous. Very, very good buck. So let's talk about his color genetics. So we're going to start in order. We're going to talk about the big five and then the extra two genes that we've talked about. So let's start with the A gene, the A series. That's the agouti series. Is he an agouti or is he something else? So there are three options in your agouti series. There is the actual agouti color. That is where you have the 3 or 5, sometimes 5, but usually 3 bands of color. Well, he's not that. You can lift up his fur, look all you like. His fur is solid blue. So he's not an agouti. The second mark is tan, also called otter. So depending on the breed of rabbit, it might be called otter. If he was an otter, he would have some brown back behind here somewhere. So let's look in amongst that blue. No brown. He'd have some brown markings on his nose. No, that can be hard to spot in a broken because they might have broken white, that broken up white color, where you're looking for the spot. But I am looking through all of his little blue hairs on the back of his head, and he certainly doesn't have any on his nose, and there's not a single brown hair to be seen. Okay, none of those light tan hairs, they're just not here. So they're not here, therefore he's not a tan. The third color in that series is the solid, the self. Is he solid? Yep. Even though he's broken, we'll deal with the broken gene in a minute, he is solid color. The color of his fur is the color all the way in. Okay, so over here is a white spot, but the color in his fur is the color all the way down. Okay, all the way to the base of the fur is the same color. No cream, no reds, nothing. All one color. And he has no otter markings. That makes him a self or a solid. So in that genetic series, the agouti is the most dominant, followed by the tan, followed by the self. So because he is showing the most recessive of all of the genes, we know that he's a double little a. Okay? 2 little a's. That is what he is genetically. He does not carry the gene for agouti and does not carry the gene for tan. Therefore, he can't pass those to his babies. Let's move on to the second gene, the B series. This is the, are you black or are you brown? There are only 2 options, black, brown, also called chocolate. So, he is definitely not chocolate. Okay? Chocolate is the recessive, black trumps it every time. So he has at least 1 copy of the black gene because blue is a dilute of black. Okay? If he was a dilute chocolate, he would be a lilac color. He's not a lilac. He is 100% a blue. So he carries a dominant black gene. What's that second gene? I don't know. I would only be able to maybe figure it out if I bred him to a female that carried only the chocolate genes. So a chestnut or a chocolate or a lilac, I would have to breed him to one of those colors in order to know if he carried that recessive chocolate gene. So I don't actually know. He's been bred to my girls, but as far as I know, nobody carries a chocolate gene in my herd. So, except for our Rexes. Our Rexes have the chocolate gene. But as far as I know, he doesn't. However, I can't rule it out. Okay, even if I bred him 4 or 5 times to a straight chocolate girl, there's no way I could actually rule it out. because he could just be throwing that black gene every single time. And that's a possibility. Just because we say you have a 50-50 chance to throw each gene doesn't actually mean anything. You could throw that same gene every single time. It's just like tossing a coin. Technically, your chances are 50-50, but you could just toss heads forever. Okay, because each time is 50-50. It's not dependent on the percentage chance before it. So, just like that, he could be a recessive chocolate carrier because he's expressing the dominant gene. I don't think he is. I tend to think he's got two big B's, but because we don't know that for sure, we write it like this. Big B, blank, because we don't actually know. If I knew, then I would just fill in that second B, but I don't know for sure. So that's his B series. What about the C series? So the C series deals with removing color. It removes first the yellow and then everything. So you have your dark chinchilla, your light chinchilla, your harlequins, and then your red-eyed whites. He is none of that, okay? So he is not expressing any of that. There's no chinchilla of either kind. There is no Himalayan, so that's important because there's no Himalayan. So he doesn't express Himalayan at all, and he's certainly not a red-eyed white. So because he hasn't expressed any of that, he's that first dominant gene, that big C, which means nothing happens on the C series. I honestly don't know what his second gene is. No idea. There's no way to know unless I put him to a female that carries some of those genes. So if I want to know if he carries that recessive red-eyed white, I need to put him to a red-eyed white female. And if they had any red-eyed white babies, then I would know. But since I haven't done that, I actually don't know. So again, big C, blank. That's all we know. We know he does not express any C series genes. He's just normal. Just normal. Wonderful, but normal. What about the D series? D series has only two options. Not dilute, which is dominant, and dilute, which is not dominant. It's recessive. He is displaying dilute because he's blue. Blue is the dilute of black. Since that's a recessive trait, I am comfortable calling him a double dilute. Two little d's. Okay? That's what he is because he's expressing the recessive gene. So he does not have an intense color gene. He doesn't have that big D because it would take the place of this beautiful, beautiful blue. He would be black instead. So he definitely is a double dilute. Two little d's. Next, we're going to talk about the extension series, the E series. This series deals with removing the color and moving it around. So this is where you get your harlequins. This is where you get your torts. This is even where you get your steels because it lifts the color and just kind of moves it. It might move it along the hair shaft like in a steel or in a tort. It might move it around the body like in a harlequin, but it moves the color around. So he doesn't have any of that. He's certainly not a steel because steel is very obvious. Okay, if he had steel genes, you would see a heck of a lot of ticking. He doesn't have any ticking, so he's not a steel. So he's definitely not a steel. Steel is the most dominant. The next most dominant is nothing, just normal. The color doesn't move around the body at all. That's what he's got. The next two in order of dominance are harlequin and tort. He's not expressing either one of those, so he definitely has one big E, okay? However, I do know what that second gene is. How do I know what that second gene is? When I put him to Gemini in early 2024, they threw a tort, a blue tort. He can only throw blue dilute. That's it. And apparently, he can throw tort. So tort is the most recessive along that E series. Even harlequin beats tort. Tort is at the very bottom. So if he had a tort baby, he's got a tort gene because it can't dominate anything. So he's got a hidden tort gene. So his E series looks like this. Big E followed by little e. That little e is the tort. Okay? That's what his series looks like because we know that second digit. Even though he's not expressing it, he's had a baby that did. So that baby got that gene from somewhere and had to get 2 copies. Since it had to get 2 copies of that gene, it gets one of them from him. So he's got the gene for tort. Next up, we are going to talk about the broken gene. I have your hair up my nose. You're wonderful. Yes. Your hair is up my nose. He's shedding right now. Anyway, next up, the broken. Okay? He's a broken. Very clearly a broken. And broken is dominant. So if you have 1 copy of a broken gene, you're a broken. But if you have 2 copies, you're a Charlie. So Charlie is when you are more than 50% white. He is not. He is very clearly more than 50% color. So he is a standard broken. So since he's a standard broken, okay, very standard, that means he only has 1 copy of the broken gene. So his genes look like this, okay? EN for the dominant broken, followed by an unbroken gene. Those are his genes because if he had 2 copies of that broken gene, he would be a Charlie, and he's not. He would be very much like Celeste, and he's not Celeste at all. Yes, you're a good boy. You are a good boy, even though you're not Celeste. Yeah. Anyway, next up, the Vienna gene. The Vienna gene is what's responsible for blue-eyed whites. Okay. We've had blue-eyed white babies, but he's obviously not a blue-eyed white. The Vienna gene, if you only carry 1 copy instead of 2, so 2 copies gives you blue-eyed white. 1 copy means you are either a Vienna marked, meaning you show some Vienna signs, white where it shouldn't be, or blue eyes, or you're a Vienna carrier, which means you don't have any unexpected white, and your eyes are not blue, but you still have that gene hidden in your genetics. So he does not have, oh, I'm kicking something, there we go, but he does not have blue eyes, okay? His eyes are a beautiful chocolate brown, and he doesn't have white where we don't expect it, okay? He's a broken, so he has white, but none of it looks like Vienna white, okay? There's no big giant marks where we wouldn't expect a big giant white mark. However, he is definitely a Vienna carrier. Now, Vienna is incompletely dominant, so it's a big V is the Vienna gene. Non-Vienna is the little v. However, we know that he's got a big V and a little v, okay? Because he might not look like it, so there's no Vienna look to him, but he and Gemini can produce blue-eyed whites. We did in 2024. We had a couple of blue-eyed white babies. So in order to get those blue-eyed white babies, both parents had to throw a Vienna. Now, we all know Gemini's a Vienna. She's got blue eyes. But he doesn't have blue eyes. He's still a Vienna because his babies were blue-eyed whites. So he is throwing that Vienna gene as well. When he throws it and Gemini throws it, they get blue-eyed whites. So he definitely is a big V and a little v, meaning he is useful in my Vienna program. Even though he doesn't look like he would be, he is, because he has that gene. So this is his entire genetic code. Okay? That's his genetic code. He is absolutely 100% a self. Okay? No, nothing else. A black. A solid. So no expression of C. He is a dilute. He is, again, solid color, no expression of E. He is broken. And he has the Vienna mark. That is his known genetic code. That's as much as we know right now. But knowing that, we can put him to a complementary female and maybe get the babies we want to get. That's what we do. We breed the rabbits that have the genes we want to get the babies we want. That's how it works. So I hope you enjoyed playing Genetic Detective with me here today. We will continue doing that with a few of our other rabbits, at least the rabbits where I know most of their genetics. It's not very much fun if we can't figure any of it out. But since we can figure it out, we're going to continue to do so over the next few weeks. That's about it for us here today at Andersen Acres. We'll see you tomorrow.